Hey, have you ever wondered how 3D graphics work? No? I did, and that prompted me to make a 3D renderer. I'll brief you through the process of making it and try to explain everything on the way. Alright, let's get to it. The beginnings are the hardest. You have to ask yourself what technology you wanna use, because there are a lot of them. I went with C++ and OpenGL because it's a great way to learn how graphics actually work under the hood. I started by going to this great website called Learn OpenGL, and I recommend you do the same if you want to try creating something yourself. The link to the website is in the description. So, OpenGL is a graphics API, which means it's a program that allows you to communicate with the graphics card through code. Unfortunately, it's not that simple, and to just create a window and render anything on it, you need some libraries. I chose GLFW, which handles window creation and input. The other one is GLAD, which loads the OpenGL functions so you can actually call them. Both are open source. With everything planned, I created the project in Visual Studio, set up the libraries, and got to the hello world of OpenGL graphics. A triangle! Yes, you heard that right. The first thing that almost everybody renders is a triangle. It even has a color and there is a background, so it looks promising. Now you might be asking,
What the hell, man? You were supposed to show some cool 3D stuff and you're showing us a triangle?
yes, you need to start somewhere. Before we even talk about 3D, let me tell you how I made that triangle. To draw anything in OpenGL you need shaders. The two most important ones are a vertex shader and fragment shader. A vertex shader tells the GPU where to place each point in space, while a fragment shader tells it what color each pixel should be. Every single object you see on the screen goes through these two programs. Now, how do you go from a 2D triangle to a 3D object? Basically, you add more vertices and align them across 3 axes, but more importantly, you add transformation matrices. These contain the math that makes the GPU understand perspective, camera position, and depth. For example, for a cube you need 36 vertices, because the cube has 6 walls, which are squares, but the GPU draws triangles, so 2 triangles make 1 square, which gives us 12 triangles consisting of 36 total vertices. In order to actually see the cube in 3D, you need a camera that moves around the 3D world. I created one and gave it some smooth movement controls, and now the cube can be observed from all sides. Since this was my first OpenGL project, I decided to start small. The main objectives were a 3D camera, a 3D cube, and importing your own 3D models. To do that, I used a library called Asimp. It handles the parsing of 3D file formats for you, though integrating it fully with multiple meshes and materials still takes some work. Alright, I think I'm done. Let's import something. Yeah, that's not quite right. After a few fixes, the program supports importing your models. Now the question is, what do I even import? Whatever you want, really. It just has to be triangulated, meaning the geometry should consist of only triangles. For example, I added the Stalker entity from my horror game, and by the way, if you haven't played the game or seen the video on it, I'll leave the links in the description, you should check them out. At this point you can't really tell it's the Stalker because he's just orange. To fix that, I added support for textures. I used a library called STB, which helps with loading images of various formats like PNG, JPG and many more. The tricky part was UV mapping. Every triangle's vertices need to be mapped to exact coordinates on the texture image, and then you have to tell OpenGL how to sample that image correctly. It was probably the hardest part of the whole project, but after some time it all came together. This is the final result. I'm pretty satisfied with it, but I think I'm going to stick to making games for now, so stay tuned for more bangers. Join my Discord to connect with other devs like me and get info on future videos. And remember, no matter what you're trying to do, it's never the perfect time to start, so start now. Alright, that's it for this video. I'll see you in another one. Don't forget to like and subscribe if you found this helpful.